principle of Van de Graaff generator. It's an experiment. That experimental setup is there. You just type in YouTube, no, Van de Graaff generator. You get one video, watch that one. Because again, that it will take almost 1.5 hours for me to explain that experiment. All that one is a self-explanatory and not part of syllabus also. This called like a principle of Van de Graaff generator is what I'm discussing. Okay, now what do you expect? The charges given are Q and 6Q. Okay, just general question. Which charge is more? 6Q charges more than Q, no? Then when a closed switch, what do you expect? Some charge will flow from outer to inertial, so that how long the charge will flow? Go back to electrostatics. The charge will move from higher to lower potential. Am I right? Positive charge will move from higher to lower potential. Okay, similarly here also same thing. How long the flow of charge will occur? Till potential of shells become equal. E equal to dou V by dou X, the idea what we have generated. If you release a charge, positive charge in an electric field, it will move from higher to lower potential. Same thing here. Now charge will flow from outer to inner shell or inner to outer shell. We'll determine the potential difference between them. We'll calculate potential difference. We'll see. Then will some Q charge from outer shell will flow to the inner shell, or some Q charge from inner shell, some charge from inner to outer shell will flow. We don't know anything. Let's work out. So after closing the switch, after just closing the switch, what charges are there? After closing the switch, it's a conducting switch, no? This particular switch is what happened made up of iron. These are conducting shells again. Copper, thin copper shells. Two thin copper concentric shells. Huh? Let's get into this one. What actually happened? So I'll assume that some Q charge will flow from inner shell to outer shell. And what was the charge here? I'll give red color. I agree this, I think good justification. Some Q charge has flown from here, from inner to outer shell. No, as this iron, why no? So we know what is iron? It's a conductor. So when you join two conductors by an iron wire, what will be the potential of those two conductors? Should be same, because iron is an conductor and conductor must be equipotential. So what this wire will do, will make potential of shell A equal to that of B. Okay, I'm interested like how much of charge, no? Like how much of charge has flown through the wire. That was our primary question. Okay, let's get into potential now. Potential of A equal to potential of B. I'll do here. Now, why potential of shell A equal to B? Because they're connected by a conducting wire. And conductor is an equipotential. Okay, what is potential of shell A? Looking at the diagram, K R plus K 6Q plus Q 3R is equal to K Q minus Q 3R. Okay, fine. Potential of shell A and B. Similarly, like just now we learned, no? Potential of shell A. Charge on shell A by radius R. Then this particular point will lie inside the shell B. So therefore 6KQ plus Q by 3R. If I stand here, first only due to potential of shell A, KQ minus Q by 3R, then due to shell charge on shell B, this much here. Okay, these two will cancel out. So I'll end up with the equation of like this. When this will be valid? This will be correct only when mathematically when Q equal to Q. If small q equal to capital Q only, then on this equation become valid, no? So then what does it mean finally? The whole charge on the shell A will flow to the outer shell. Looks strange, but this is what happens. So what is the final? Finally, what happened? We'll get here 7q charge. And here 0, no charge. Agree this? So what was the what we expected? 6q. So some charge from outer shell will flow. No, the charge from inner shell is flowing. Okay, next what I do is, instead of this q, no, let me bring minus q. Then also that minus q will flow to the outer shell. So irrespective of potential greater than VA, greater than VB, VA less than VB, the charge will flow from inner to outer shell only. Now I'll ask you one of the best question. Which will be at higher potential, VA or VB? Who will answer? Looking at here. So now shall we give answer that one? The charge has flown from inner to outer shell. The reason potential of shell A is greater than B, that's why it has flown. That was the reason. Okay, so time being, okay, there's a reason. The charge flows from inner shell A to outer shell B as agreed. I think the shall we give reason? Okay, next is student, what happened instead of this? Let me keep minus q. What changes will come? Again, you're going to write minus q. Minus q. Then we'll solve it. I agree this. I'll change the data because we have to verify for VA less than VB what conditions will arise. Okay, now the second condition is
sir, if we take a q minus q, we will get the resultant as a minus q, no sir? The charge transfer would be minus q will get, no sir?
what you are asking.
Sir, if we take you substituted k into capital Q minus small q by r, no sir? If we take instead of small minus q, if we take plus q.
Not like some charge here also open. There's some charge will leave. What charge will leave? We don't know.
Yes, sir.
I don't know. No. At least can you say about potential now? Which will be at higher potential? So first we'll calculate potential. Potential of A equal to K minus Q by R, K 6Q by 3R. This will be KQ by R. VB equal to how much? K minus Q 3R. Which is at higher potential now. VA less than VB. Before closing switch, this is before closing switch. Similarly, here also you can calculate the first diagram. This is I brought minus Q. All of you, I changed its situation. Charge on shell A is negative now. Earlier the charge on shell A was positive. I changed problem. There's a case 2. What we discussed is case 1. See, all these are conceptual things. Until through numerical only we can analyze. Not possible. Theoretically, just I can't write sentence. Yeah, I think you have everything in front of you. Make observation. No. VA less than VB, I'm very sure. I'm going to close switch. After closing switch, what will happen? I'll draw a small diagram. I don't have space. R, this is 3R. No, in this case, it will be what will be the final charge? I know some charge left, minus Q, negative signs, no? Yeah. Minus Q, this was plus 6Q. So what shall we do? Some charge left. Charge left means will become, let's solve again, since they're connected by a wire, no? Iron wire. So what happened to potential of shell A and B must be equal. Let's write the same equation, K see this again, what is the basic necessity condition? So this minus Q should be the equal 0. So therefore, what should be the Q charge? Should be equal to minus Q. So how much of charge has flown? The whole native charge will flow to the earth. So finally, what will be our diagram? Our diagram will be like this. I have space only this much. I'll end up here. So what is the conclusion we are going to make is the final charge, how much here will be 5Q when you join by a wire. So what we thought, like, since VA greater than VB, charge has flown from inner to outer shell. Look at here now. VA greater than BV or VA less than VB, irrespective of that, what all charge present on inner shell will flow to the outer shell. This is what I'm going to use to produce a charge on a shell. How to produce charge on a shell? It's not that easier. Not like some charge will present in some bottle. I'll take spoon, I'll sprinkle it. Not there. We have an like a Van de Graaff generator. It's an experiment. Through that experimental setup only, I can produce a charge on a shell. For namesake, I'm saying charges are given to shell. To give that, I need minimum half an hour. To produce a charge on a shells, no, we need some half an hour time. It's experimental setup. So I think this will be much easier, no? So I need not to bother. So like, what will be that? What is the charge on a shell that will be transferred? So I want to like a charge in this particular shell. So I'll give some charge to shell A. I'll join a wire. The whole charge will flow. I think very fine, no? What charge you give to shell A, that will go to the outer shell when you close switch. I need not to bother any mathematics here. Whether I'm giving positive charge, whether I'm giving negative charge, nothing. What all charges there will flow to outer shell. Irrespective of what charge is present here. So you bring 100Q. Sir, 100Q, Q. So 100Q. So more charge, sir, some charge, let it flow like this. No. Even if the 1 lakh coulombs, here 1 coulomb, the 1 coulomb will flow from inner to outer shell. Whether inner charge on inner shell is positive or negative, whether it is greater than or less than. Even if there's a greater, there's lesser, still it will flow. There's a lower value, there's a higher value, still it will flow. So what is the condition now? When you join two concentric thin conducting shells by a wire, conducting wire, what all charge present on shell A will flow to the outer shell. The charge Q flows from inner shell to outer shell B as VA less than VB. Yes. So is it a correct statement? Not must, may. Even so I can write sentence, no, the charge Q flows from inner shell A to outer shell B as VA less than VB. Yes. So there is nothing called like this is something like a only when VA greater than VB charge flows. VA less than VB or VA less than V. So what shall I write? The charge generalize, I'll make it VA less than VB or VA. I think this statement will be very generalized one. The charge flows from inner shell A to outer shell B as VA greater than or VA less than VB when joined by a wire. Without joining wire, charge cannot jump. Yeah. This will become generalized statement. So even the Van de Graaff, no, he was surprised when he got this one. He was surprised. Then he could not believe. Then he did experiment. Then finally concluded, oh yeah, this is a very thing. So I think based on this now, it has become very easy for him to generate a charge now. I need not to bother anything. No, what all charge of shell A will go to outer shell, irrespective of VA greater than VB, VA less than VB, whether this is negative, this is a positive, this is higher, this is lower. Irrespective of any conditions,